So here we have a power series and we're looking for the interval and radius of convergence. So we're going to use the ratio test. We're going to take the limit as n goes to infinity of, we want the n plus 1 term, and we can ignore this negative 1 to the n because inside the absolute value signs that would disappear. So we're going to have x minus 3 to the n plus 1 over 2 to the n plus 1 plus 1, and then we're going to divide that by the nth term so we can multiply by the reciprocal, which is 2n plus 1 over x minus 3 to the n, and we need this to be less than 1 for convergence. So you can do to simplify, x minus 3 to the n plus 1 is x minus 3 to the n, x minus 3 to the 1, so we can get rid of the n part with this one. Now let's go ahead and bring the x minus 3 out in front of the limit because it doesn't involve n. So we have absolute value of x minus 3 and then the limit as n goes to infinity of 2n plus 1 over 2n plus 3, because I went ahead and just distributed this through and then combined like terms, and we're interested in when that is less than 1. Should be able to see, you might be able to start doing these in your head, that this limit's going to be 1, because if we divided everything by n in the numerator and the denominator, these would be gone and these would be over n, and then these would go to 0 as n goes to infinity, and we'd be left with 2 over 2, which is 1. So we have absolute value of x minus 3 is going to be less than 1. So our radius of convergence is going to be 1. And let's go ahead and write this as an inequality. Negative 1 is going to be less than x minus 3 less than 1. We can add 3 to both sides and have 2 less than x less than 4. So our interval of convergence is going to go from 2 to 4, but do we include the endpoints? So let's go ahead and test 2. So we first go back to our original here, and we're going to let x equal 2 and see if we have a convergent series. So we have negative 1 to the n. If we put a 2 in for the x, we would have another negative 1 to the n over 2n plus 1. So the numerator would combine and just give us a 1. And my first thought was a comparison test, but because it's 2n plus 1, my absolute value would be going the wrong way. So a comparison test is not going to work. A limit comparison would work, and also the integral test would work on this. Maybe we'll do the integral test for something different since it's been maybe a little while. So we're going to look at the limit as b goes to infinity of integrating from 1 to b, 1 over 2x plus 1 dx. And so as I go to do that integral, I'm still going to have the limit as b goes to infinity of the natural log of 2x plus 1, and then I need a 1/2 out in front because of the chain rule, and we're going to evaluate that from 1 to b. So I'll go down here at the bottom over to the left. So we have 1/2 times the natural log of 2b plus 1 minus the natural log of 1. And we know, of course, the natural log of 1 is 0, and then what I didn't write was the limit. We still need this limit as b goes to infinity, and when we do that, we know that this natural log graph just continues to get larger. And so this goes to infinity, the integral diverges, and so therefore the series also diverges, so we will not include the endpoint of 2. Now let's go ahead and check the endpoint of 4. So if we put in a 4, we would have negative 1 to the n over 2n plus 1, and this part would become 1 to the n, so we don't need it. And that's an alternating series, and the terms go to 0. So, because if I looked at 1 over 2n plus 1, I can see that as I let n go to infinity, that's going to go to 0. So by the alternating series test, this series converges, and so I need to include the 4. So my interval of convergence is going to be from 2 to 4, including 4.